Welcome to Two Projects. In this video, we are going to explain the project Sustainable Approach of Reduced Waste using Optimized Machine Learning Algorithms for Predicting Crop Yields. Before diving into the execution, let me give you an overview of the project. So, the project aims to transform agriculture by using machine learning techniques to predict crop yields. Traditional methods based on historical data lack accuracy and efficiency. So the project focuses on developing robust models that consider factors like weather, soil health, crop type, and historical data. So these models provide farmers with insights into optimal planting schedules, resource allocation, and market strategies. And the project also aims to recommend suitable crops based on environmental conditions and farming practices, maximizing yield potential and mitigating risks. Additionally, the project also aims at creating an automated waste detection system, promoting sustainable farming practices, and enhancing overall agricultural efficiency. The project begins by collecting the required datasets, exploring the datasets, followed by pre processing the datasets, visualizing to understand the patterns, selecting the important features. And the project uses different machine learning algorithms such as decision trees, MLP bagging classifier, that is random forest, and voting classifier to develop predictive models for yield prediction and crop recommendation. And image processing and data augmentation techniques are used to pre-process agricultural waste images, while deep learning architectures like YOLO are used for waste detection. A user-friendly web interface built using the Flask framework with SQLite allows farmers to input parameters for crop and yield prediction and waste detection, receiving insights and recommendations. So, the project's insights inform policymaking and regulatory efforts, ensuring food security, environmental sustainability, and economic resilience through efficient and sustainable agricultural practices. So this is what happens in this project. Now we look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So these are the algorithms built for both crop and yield prediction, decision tree, MLP, bagging classifier, and voting classifier, combining bagging with random forest and decision tree. And these are the algorithms built for waste detection. So we have trained all these models, we have compared them, and we have observed that voting classifier has outperformed all other prediction models in all the performance metrics, accuracy, precision, recall, and F1 score for both crop and yield prediction. And YOLO V8 has outperformed YOLO V5 and YOLO V7 in waste detection. So we have deployed voting classifier and YOLO V8 for crop and yield prediction and waste detection. So we will be executing the project using Flask web application. Before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is data folder in which I have data for crop yield prediction models and crop recommendation. So I'm opening crop yield data. So we can see I have columns like rainfall, fertilizer, temperature, nitrogen, phosphorus, potassium. And the last column here is yield per acre. It is the target variable which we'll be predicting in this project. So we will be training the crop yield prediction models on this dataset. Coming to crop recommendation dataset. So here I have columns like nitrogen, phosphorus, potassium, temperature, humidity, pH, rainfall. And the last column I have is label column, in which I have different class labels of different crop types: rice, maize, chickpeas, kidney beans, pigeon peas, mung bean, lentils, pomegranate, banana, mango, etc. So on this dataset, we'll be training the crop recommendation models. So this is about the datasets of crop yield and crop recommendation models. This is static folder which consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And these are dataset folders for YOLO v5, YOLO v7, and YOLO v8 separately. I'm opening YOLO v5 folder. We can see I have train and validation folders here. I'm opening train folder. I have two subfolders again, images and labels. In images folder, I have these agricultural waste images. And in labels folder, I have their associated annotation files. So here each annotation file corresponds to an image file in the images folder. So this annotation file corresponds to this image. Similarly, each annotation file corresponds to an image file in the images folder. So these annotation files follow YOLO format where each line, this is the line, represents a detected object. That means here we have 3 lines, which means there are 3 objects detected in this image. As this annotation file corresponds to an image file, so in that image, there are 3 objects detected. So here first column is the object's class index, followed by the bounding box coordinates normalized to the image dimensions. So these are the bounding box coordinates of the detected object. This is the X limit, this is the Y limit, and this is the width, this is the height. So similarly, I have object's class index followed by its bounding box coordinates in other annotation files also. These annotation files correspond to an image file in the images folder. So on these images and label files, we'll be training the YOLO v5 model as they are in the YOLO v5 folder. So here I have a validation folder. I have images and label files here again. So on these images and label files, we'll be evaluating the YOLO v5 model's performance. In the same way, I have images and label files in YOLO v7 and YOLO v8 folders also. Each folder contains the same images, but they are annotated differently. The annotation files or the label files will be changing because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders like this keeps the dataset organized and ensures that each YOLO version receives the correct annotations to function properly. And this is the sample folder in which I have test cases for detection. This is app.py file. This .py file contains the information related to front-end logic. It includes code in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the train models. These are Jupyter source files which contain a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. So these are respective Jupyter source files for crop, recommendation, detection, and yield prediction. And these are sample crop and sample yield CSV files in which I have test cases for crop recommendation and yield prediction. This is signup.db file. This file is the data. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command executes the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Here we can see a sign up link, click on it. So if we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the predictions page. So here we can see a prediction link, click on it. So here we can test crop yield prediction system, crop recommendation system, and waste detection system. First, we'll see the crop yield prediction system. Click on yield link. So here we have to fill in these parameters and click on predict button to get the crop yield predictions. So rainfall measures precipitation impacting soil moisture, critical for plant hydration. Fertilizer supplements essential nutrients, enhancing soil fertility and crop growth. Temperature regulates plant processes, impacting yield, so it is necessary. Nitrogen, phosphorus, and potassium are vital nutrients crucial for plant growth, influencing crop yield. So now we'll fill in these parameters. Rainfall would be 454, fertilizer would be 60, temperature is 38, nitrogen is 65, phosphorus is 20, and potassium is 16. Now click on predict button. So here we can see the result, that is the crop yield is predicted as 9 quintals per acre. So according to the given set of parameters, the application has predicted the crop yield as 9 quintals per acre. Click on prediction link, click on yield link. We'll try giving another set of parameters. This time rainfall would be 1150, fertilizer is 80, temperature would be 26, nitrogen is 75, phosphorus would be 21, and potassium is 20. Now click on predict button. So here we can see the crop yield is predicted as 11 quintals per acre. We'll try again. Click on prediction link, click on yield link. This time rainfall would be 460. Fertilizer is 55. Temperature is 38. Nitrogen is 61. Phosphorus would be 20. And potassium is 18. Click on predict button. So we can see the crop yield this time is 7 quintals per acre. So the application has predicted the crop yield according to the given set of parameters as 7 quintals per acre. So in this way, we can give any set of parameters and can get the crop yield predictions. So rainfall would be 1241 this time. Fertilizer is 77. Temperature would be 27. Nitrogen is 78. Phosphorus is 23. Potassium is 20. Click on predict button. So we can see the crop yield is predicted as 12 quintals per acre. Now we'll see the crop recommendation system. Click on crop link here. So now we have to fill in these parameters to get the crop recommendations. So first we'll understand these parameters. So nitrogen, phosphorus, potassium are essential nutrients influencing crop growth. Temperature and humidity affect plant development. pH levels and rainfall impact soil acidity and moisture respectively. Collectively, these factors determine optimal conditions for recommending suitable crops. So now we'll fill in these parameters. Nitrogen would be 101. Phosphorus is 17. Potassium is 47. Temperature would be 29.4. Humidity is 94.7. pH value would be 6.18. And rainfall is 26.3. Now click on predict button. So here we can see the result, that is recommended crop is muskmelon. According to the given set of parameters, the application has predicted that for this set of parameters, the crop suitable is muskmelon. Click on prediction link, click on crop link. This time nitrogen would be 98, phosphorus is 8, potassium would be 51, temperature is 26.1, humidity would be 86.5, pH is 6.25, and rainfall is 49.4. Now click on predict button. Here we can see the recommendation, that is recommended crop is watermelon. So according to the given set of parameters, the application has recommended watermelon is suitable. Click on prediction link, click on crop. Nitrogen would be 59 this time. Phosphorus is 62. Potassium would be 49. Temperature would be 43.3. Humidity would be 93.3. pH is 6.94. Rainfall would be 114.7. Now click on predict button. So we can see the application has recommended papaya this time for the factors which we have provided. We'll try giving some more test cases. This time nitrogen would be 25, phosphorus is 12, potassium would be 26, temperature is 28.5, humidity would be 95.6, pH is 6.43, and rainfall would be 134.8. Now click on predict button. We can see the recommended crop this time is coconut. So for the given set of parameters, the factors which we have given, coconut is the suitable crop. We'll try with one last test case. So nitrogen this time would be 11, phosphorus is 46, potassium is 24, temperature is 27.6, humidity would be 89.8, pH value would be 6.445, rainfall would be 56.5. Click on predict button. So we can see the recommended crop this time is mung bean. So in this way, we can give any set of parameters, and according to these factors, the application will recommend us the crop which is suitable for these factors. Now we'll see the agricultural waste detection system. Click on waste link. So now we have to upload any image here, and the application will detect the agricultural waste from the image. Click on choose file button. From sample folder, these are the test cases I have. I'm selecting this image. Click on open. The image has been loaded. Now click on upload button. So here we can see the application has detected the waste, the agricultural waste. It has drawn a bounding box around the detected waste. And here we can see the label, that is fruits and vegetables waste. The application has classified this waste as fruits and vegetables waste. And beside the label, we can see a confidence score, which tells us the confidence level of the system in classifying it as fruits and vegetables waste. Click on back, click on choose file. We'll try with another image. We'll try with this one. We can see the application has detected the stubble waste. We can see the bounding boxes drawn. We can see the class label. And beside the label, we can see the confidence score, which tells us how confident the application is in classifying it as stubble waste. Click on back, click on choose file. We'll try with this image. Select the image, click on open. The image has been loaded. Now click on upload button. So we can see it has detected the plastic waste. We can see the bounding boxes drawn. We can see the label here. And beside the label, we can see the confidence score. I'll try with this image. We can see the plastic waste has been detected. We'll try with this image. So we can see dry waste has been detected here. We'll try with this image. The application has detected the dry waste. We can see the bounding boxes drawn. We can see the label. Beside the label, we can see the confidence score of the application in classifying it as dry waste. I'll try with this image. We can see it has classified it as others. The application has detected the waste and classified it as others. And beside the label, we can see the confidence score of the application in classifying it as others. Click on back, click on choose file. We'll try with this image. We can see the stubble waste has been detected. We'll try with this image. So we can see fruits and vegetables waste has been detected. So in this way, we have to upload images here, and the application will detect the waste, the agricultural waste from the image. Now we'll look at the graphs plotted. Click on the graph link here. Here we can view all the visualizations made. First, we'll look at the graphs plotted for crop yield prediction. This is sample outcome graph. which displays the distribution of labels. This is correlation matrix graph, which shows us if two variables are related or not. This is accuracy scores comparison graph, a horizontal bar graph comparing accuracy scores. So in this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So these are all the algorithms built for crop yield prediction. Similarly, this is precision scores comparison graph. This is recall scores comparison graph. And this is F1 scores comparison graph. So we can see voting classifier has outperformed other models in all the performance metrics in crop yield prediction. Now we look at the graphs of crop recommendation system. This is sample outcome graph, which displays the distribution of labels. This is correlation matrix graph. This is accuracy scores comparison graph. This is recall scores comparison graph. Sorry, this is precision scores comparison graph. This is recall scores comparison graph. And this is F1 scores comparison graph. We can see all the models are doing well. Voting classifier has outperformed all the models. It is consistently doing well. Now we look at the graphs of waste detection system. This is precision and recall graph of YOLO. This is F1 score graph of YOLO. This is confusion matrix of YOLO. This is precision scores comparison graph. This is recall scores comparison graph. And this is MAP scores comparison graph. We can see YOLO V8 is doing well in MAP and precision. It is also doing well in recall. So these are the graphs plotted. Here we can see a soil type link. Click on it. So here we can view different soil types: black soil, clayey soil, loamy soil, red soil, and sandy soil. Below them we can see a click me link. By clicking on that link, we can view some information about that particular soil type. So I am clicking on the click me link of black soil. Here we can view some information about black soil, the characteristics of black soil. And here we can view the crop recommendations. So these are the crops suitable on the black soil: cotton, soya beans, wheat, sugarcane, etc. Click on soil type. This time I'm clicking on the click me link of clayey soil. This is some information about clayey soil. These are the characteristics of the clayey soil, and these are the crops which are suitable for clayey soil. We'll try with loamy soil. So here we can see the information about loamy soil. These are the characteristics of the loamy soil. And these are the crops suitable for loamy soil. Similarly, we can see some information about the soil type, the characteristics, and the crop recommendations for other soil types also: red soil and sandy soil. Now click on sign out link. So the project transforms farming with advanced technology, predicting crop yields accurately and detecting waste automatically. By giving farmers smart insights, it boosts productivity, cuts waste, and supports eco-friendly practices. So it is about smarter farming for a better future.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.